Hello, everyone, and welcome to today's SANS webcast, Fighting Back Against Compromised Credentials, sponsored by Enzoic. My name is Carol Auth of SANS. Today's featured speakers are Jake Williams, SANS Senior Instructor, and Josh Horowitz, Enzoic Chief Operating Officer. If during the webcast you have any questions for our presenters, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found in the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Hey, thanks so much, Carol. Really appreciate it. My name is Jake Williams. I'm here to chat today about credentials and also a little review that we did of Enzoic. Of course, I'm joined by Josh Horowitz. Josh, you want to introduce yourself real quick here?
Sure. I'm Josh Horowitz. I'm the Chief Operating Officer for Enzoic. We're based in beautiful Boulder, Colorado, focused on preventing unsafe credentials from getting into your environment.
And I do want to mention here, there's an associated white paper, as Carol mentioned, that's actually in the chat, or the link to that's in the chat. She'll repost it because, of course, as you join Zoom, it doesn't copy that stuff forward for you, because why would you want that? But unlike products that almost feel like they're written by people who don't get it. This one, I gotta say, there's always stuff I look for in these. You'll see this in the white paper. For evidence of kind of been there, done that, got the T-shirt. This checks all the boxes, right? Former system admin myself, I obviously do security today and have for the last, a long time. But again, as I look at stuff that I need to bring this into an environment operationally, it's just there. All that said, let's rock forward here. So I want to talk quickly about credentials generally, and for some, next slide. And for some reason, we kind of rolled into, we're always chasing the new hotness. And the reality is that you can see it in the data breach investigation reports. You can see it in incident response reports. Compromised credentials absolutely matter, right? And nothing's changed about that, right? It's just that we've gone and chased all kinds of other stuff, and not for bad reasons necessarily, but what that brings us to is credentials. We kind of ignored these for a while, dare I say, over a number of years here. Josh, I'm interested in thoughts on this. What do you think? Ignored credentials for too long and now it's hot again, or where are we at on that?
Yeah, I think it kind of came back into the press a couple of years ago with the National Institute of Standards and Technology and publishing some of the research. So folks that were in the industry understood it, but there's a real change in how attackers are leveraging credentials, and thus there's a need for a change in how we defend. So we're happy that there's visibility brought to it at this point.
Oh yeah, definitely. And look, when we talk about like credential compromise versus like some new awesome technique where you have some bypass of some security control and then manage to load code in the kernel and get a rootkit going, that's awesomely sexy. And at the end of the day, no threat actor is going to do that if you have their credentials. If they have their credentials, they don't need to do any of that stuff, right? Bam, off to the races. Next slide. And so we talk about impacts. I don't need to tell any of you this. We see it consistently, right? But the reality is that nearly 50% of attacks we had stolen credentials or compromised credentials as a component to half of the attacks reported through the DBIR. Even that has a field of view bias. I can go ahead and tell you that as you move down market further from where the DBIR really focuses, right, to your mid and down market, where we don't have these larger, more holistic security programs, I'm going to tell you the credential compromise is way higher than 50%. In contributing, to those incidents. I'd say it probably accounts for or is a contributor in 85% of those incidents, right? And so this means that this isn't one of these things you tackle last. What I want you to hear is this is something, it's just table stakes that you need tooling and processes, and obviously tooling supports those processes to go and help with that credential, basically that credential piece. My first goal when I compromise a network, obviously as a red teamer, not as a nation state threat actor, but is to stop using malware, right? I want to get into using living off the land binaries. I want to look like a user who is migrating throughout the environment, right? Again, I need credentials to do that, right? Once threat actors have their credentials, all your detections start to suffer because we do focus, I'm going to go with probably too much in the industry on malware to the exclusion of, well, unfortunately, more table stakes stuff like this. Next slide. So as we start thinking about how is a threat actor going to use compromised credentials, I'm going to view this more as a reference slide. I'm not going to read all of these, but I do want to note the bottom bullet point here where it is hard to even quantify, right, the number of different uses for compromised credentials. If you give me the choice of, Jake, you can either be pre-positioned in this network because I can give you initial access via this malware, or I have compromised credential pairs that'll give me the same user permissions that malware is running at. Not even a question. I'm taking the credentials every day of the week rather than that malware, inserting me into the network. Because again, I know what I can do with these for follow-on actions. That malware, a single point, the old adage, right? 2 is 1, 1 is none. When it comes to credentials, right? I don't want to say unlimited use, right? But there's a lot of different places that I can use and reuse these. And so I want you to kind of think about that and put that into your your thought process here. So next slide, please. I heard some of you screaming in the background from the time I said the word credentials. Josh is laughing here because he heard it too, right? It's MFA. MFA, because Jake, you don't need to worry about that because MFA. Let me go ahead and dispel that notion for you right now. As it turns out, Azure, in the time between when we wrote the white paper and now, Microsoft 365, they're talking about having to use number matching, right, on MFA. Well, why number matching, right? Well, obviously, that's because push notification MFA, right, is something that consistently threat actors bypass. Then we have, and I say bypass, they push so many times that somebody eventually is like, yes, or mistakenly says yes, right? We, of course, also have social engineering. Consistently, we see that our users fall for social engineering because they do. We also have, obviously backup security questions that could be answered through OSINT, right? So, how enforced is the MFA? Who can rotate it out? There's change out an MFA authenticator. There are all kinds of attacks here. And I just want to throw out here that MFA is, while we certainly are not saying don't use MFA, you should 100% use MFA. You should not, just like putting on a bulletproof vest, right? If I'm going into the line of fire, I absolutely am putting on a bulletproof vest, bullet resistant vest. I am not about to pretend that I'm impervious to bullet fire, right? Or impervious to small arms, right? Any thoughts on this, Josh?
Yeah, I mean, the funny thing, Jake, has always been that MFA is technically standing for multiple factors. And yet in practice, people think about it as, well, I'm just going to try to, layer this on top of the password. And, this is going to solve my problem, like you were saying. And what we're talking about here is you really do need multiple layers to set up proper authentication security. And then each needs to be hardened as much as possible. So, we know SMS is very questionable from that what you have layer, and compromised passwords, allowing those in your organization is clearly leaving your credential layer, your password, insecure. So really, MFA should be about making sure that you have multiple strong layers.
Bingo. Yeah. Kid you not, just logged in. We were even talking about this pre-show, but I just logged into something today where it required MFA on my phone. I logged into it on my phone, and it's like the only MFA that this particular app supports, sadly, is SMS, right? And I just laughed about, I'm like, I'm on a mobile browser and you are sending this to, you have a pretty good idea I'm on my mobile browser, sending this to my phone. And I just laughed a little bit there because, anyway. Next slide. Yeah, so this is, we start talking about proactive. What do we mean by that, right? Obviously, we want to make sure users use good passwords. Training alone here is just not enough because we know that users reuse passwords. I'm going to go ahead and admit here, I, as a security professional, have and even continue to, in some cases, reuse some passwords, right? I mean, go ahead and throw stuff at me all you want. I'm human when it comes down to it. That's a big thing there. And if one of those passwords gets compromised at let's say a site with less security or a area with less security, then I now am in a position where those passwords are effectively pre-compromised. I then need to check and audit routinely to make sure that, basically that those passwords that were okay when we set them aren't compromised now. I need to understand the difference between a password being compromised and a credential pair, right? The difference there being, of course, a password is exactly what it sounds like. Credential pair is Jake uses that password, right? Because just knowing that someone used that password is interesting, and it probably makes it not a great password. Knowing that it's my password, whole different ballgame from a risk standpoint. And then not only need to be able to differentiate that, but because it's different risk, I need different response options around that. And I have to scale it with no impact to the user because, oh my gosh, right? DoD tried this years ago with passwords where they're like 16 characters with no two numbers next to each other and special characters and change them every 30 days. Our best password cracking rates, are all DoD contractors. Why? Because they're all keyboard walks, right? And so it's just, I mean, we know you can educate the heck out of users and still you're going to get bad results, right? Next slide. So first, I need to ensure users choose good passwords, right? Again, we know users are going to choose bad passwords. I need a system that is A, going to identify when they have a bad password, and B, make sure that they're not doing something crazy like, password 1 and then the next rotation time, password 2, password 3, to the extent that we are rotating passwords. And by the way, if you're falling onto the NIST guidance, so you don't need to rotate passwords anymore, you need to really read the guidance there. It's not a matter of you don't need to rotate them. It's basically that strong, not compromised credentials don't need to be rotated every 30 days. We're kind of past that idea, right? But you got to build off that foundation in the first place, right? So password rotation being an issue, and I know some folks for different regulatory frameworks are still rotating passwords regardless. Right? Next slide. And so then knowing, are my passwords pre-compromised, right? So I don't want users using a password that already is out there on some known list someplace. That sounds like a bad plan. And so a reason for this is that, I have all of those in word lists. I have word lists with, gosh, I think I'm up to like 100 and some odd million passwords, right? And so those passwords, even with salts, right, are going to be cracked nearly instantaneously because they're known passwords that people have used. And we know that people are creatures of habit, right? And are likely reusing those elsewhere, right? So a bad password equates to an immediate crack if that password credential material, even salted, right, is ultimately leaked, right? So next slide. And then continuous validation. It's great to know, because again, it's instantaneous crack. It's great to know that password wasn't in a list, right, or at least a publicly available list or even dark web available list when that password was set. But especially now that we're not pushing the rotation of passwords as much, I do need to know if it got hit later. That's a big problem for me, right? And so again, checking at the time of the credential being set, it's necessary, but not sufficient for security teams from that perspective. I need to know, I need some of that continuous validation rolling. Again, this is a big piece that's missing. And I know what you're getting ready to ask, because I certainly did. And it's how are we going to do that validation securely? And I see Josh smiling already because he's got all the answers for this. And in fact, is going to show us a demo of this in a way that because I certainly don't want to turn around and be like, hey, Josh, here's all my hashes. Now go forth and do awesomeness. I'd be like, I'm out, brother. That is not going to happen, right? So I need that validation siding, and we'll talk about the magic behind how that works in a little bit. Next slide.
Hey, just real quick on that one, Jake. I think the game changer point, I think, is really relevant because we've operated for how many decades now that a password was strong if it met certain algorithmic rules. So the number of different character types, the length, those are types of things that once you pass whatever the definition is of a strong password, those things are static. They don't change. We're in a new world now where what you're looking at is a blacklist of compromised passwords, those that have been found in cracking dictionaries and found in third-party breaches. That changes every single day. So the nature of the tooling, and again, we'll talk about this, is new and different for actually being able to address it. You didn't used to have continuous checking. Now you do need to have continuous checking because the definition has changed.
Agree wholeheartedly. Yeah, definitely. And this last point is, it's probably one of those critical points to take away from this, right? It is understanding risk. Knowing that Jake uses knowing that I've used a bad password, one of many bad passwords that are on a list someplace, again, is important. But a threat actor being able to tie that credential pair together and say, this is malware Jake and his password is X, right? If I've used that anywhere, I probably reuse it. In fact, I can look at a compromised credential pair and be like, that is definitely reused someplace, right? And Josh, I'm sure, has seen enough to do the same, right? These compromised credential pairs represent just orders of magnitude more risk for an organization. And that means that any proactive monitoring solution that we're going to use has to differentiate between those, or I'm stuck in a position of pretending everything is the same risk level when in fact it is not, right? And that leads me to overreacting to some risks, and it leads me to and there is a real cost, right, to overreacting to a risk where we just say, you know what, anybody who has a compromise or that is using a password that shows up as compromised, we're locking them out. Well, that's help desk time, that's lost work time, that's, whereas I may be able to wait a while there, right? Maybe it's some odd days, right? Whereas it's compromised credential pair, you got 4 hours, right? Or whatever, or maybe it's an immediate lock, but we can make those risk decisions with better data, right? And this becomes critical. I don't want you to lose the forest for the trees and think this isn't important, because just, again, I can't overstate how important this piece of it is, right? Next slide. Okay, I just mentioned response options, right? If all this does is generates a ticket and sends it to a CTI team someplace or a help desk or whatever, we're going to have process fail upon process fail, right? And so, then we're in a worse situation where we knew about something, but we failed to act appropriately. And so we need a method for ultimately getting flexible response options. Again, especially with remote workforces, I can't just lock out an account, right? I'm guaranteed to have a productivity loss at this point as these folks engage with my help desk. And then, of course, that now opens up yet another opportunity for social engineering, because now you have more people engaging remotely with the help desk, right? So I want none of that, ideally, right? So I want something that maybe can give the user, and again, dynamically give the user time to change something that was just detected. If I know it was just detected today as bad, I can start working and say, okay, well, historically, 4 business days or 1 business day or whatever we accept as a risk is okay here, right? And so being able to configure that and make that part of a platform and not something I have to go to SOAR for, man, fantastic. Right. And of course, I've already mentioned the delta between a compromised password versus the compromised credential. Our response options must also fit into that as well. Next slide. And then finally, we're going to talk about this, right? Credential checks and privacy, right? Because the second somebody's like, hey, just give me your ntds.dit, right? I'm kind of like, and no, not at all, right? So I need a way to preserve privacy. I certainly don't want, Josh or his team effectively Googling for my, hashes. That sounds like a really bad plan, because in order to do that, they have to have my hashes, right? Not to mention the fact that is not fast. It's actually the opposite of fast. It's excruciatingly slow. And so we need our credential checks to not only be performed in a privacy preserving manner, but also one that lends itself to high performance, right? And so again, Josh will go through some of the magic of how this happens, but I want to highlight this as selection criteria and also just to get it out of the way, right? To note that you need to be thinking about this. So the next slide. And with that, I'm going to wrap this up here. Note that anything you're going to do for credential protection has to be flexible, has to scale, right, to whatever the size of our Active Directory domain or domains are, has to preserve privacy. With that, Josh, I'm going to kick it over to you. I know you got a demo and a couple of slides to go through as well, my friend.
Sure, great. Thanks, Jake. All good stuff. So as I mentioned, Enzoic is all about hardening that password layer. It's the layer that you're already using. It's that you've already invested in. We're comfortable with that concept that you said before about it not being credential, not being sexy. That's okay with us. Our job is to make sure that that layer remains secure. We have a bunch of APIs that allow you to access this programmatically, but our primary solution is an integration with Active Directory that also works with a hybrid Azure AD environment. And this slide illustrates kind of the flow associated with it. There's 2 primary use cases that are illustrated here. One is the checking at the time that the password is being created. So we'll do a real-time check against frankly, there's multiple billions of passwords that are in our database. It is a partial hash check. That's how we do it securely. We do not want your password. We do not want your hash of your password. We take just a few characters off of that hash. That does get passed to us and allows us to query our database and pull back full hashes that allow you to do the actual checking locally in your environment. So that's done in extremely low latency. It's built for performance. So we're talking about around 250 milliseconds round trip to be able to get that response back. So people are not waiting seconds to be able to determine whether a password is good or not. That's how that it comes back to the user. We have a custom error message that's displayed to provide a little bit more information about why it didn't pass. But then the second key piece, and Jake hit on this in his presentation, is the continuous monitoring. We recheck daily because our database literally changes by, it's over 10 million passwords every single day, because we have a dedicated team that goes out and collects and maintains this information so that you don't have to. And then we would allow various forms of remediation in the second use case. So what do we do if we found a password that has become compromised? We can allow you to require a password reset. You can even set a variable amount of time or disable the count or just use notifications. Ultimately, you end up with better security by keeping unsafe passwords out of your environment. I'm going to have a quick demo, but just the last thing I say before that is the key to this type of solution is the data, frankly. In order to be able to turn this from a weapon used by hackers into a defensive tool, you need to be able to get more than just the static lists, the big publicized data breaches. We have a dedicated team that goes out and does this. We use some automation as much as possible, both in terms of the gathering of it, but also in terms of the ingestion and the normalization. So there's a really short turnaround time between our collection of the data and in making it available to users. But the key is this requires work, and we do it both for passwords as well as full credentials. There is a YouTube demo. I'm going to switch the screen over. You'll get to hear somebody else's pretty voice for under 6 minutes that walks you through how this solution works.
Welcome to this demo for Enzoic for Active Directory. Enzoic is a password screening solution designed from the ground up based on modern password best practices and NIST guidelines. Let's walk through all the key features. We are looking at the console app where settings are defined and you can see the status in your environment. The System Health tab checks for a regular heartbeat on each domain controller to ensure Enzoic is always running. Administrators are alerted if there are service problems. In the monitoring policy section of the console, you can set up your policies and apply them to different populations. For instance, you may want different rules or perhaps just different actions when a compromised password is detected based on the type of account. You can define who you'll protect by selecting specific users, groups, OUs, and containers. The Password Changes tab makes sure users' passwords are checked when they are created and whether Enzoic should check during administrators' password resets. For instance, via the Windows AD Users and Computer app. The Continuous Password Monitoring tab enables the ongoing daily auditing against the latest data breaches. Other services rely on static or less frequently updated sources. Once a password becomes unsafe, you can have the user change their password on the next login or after a preset delay. Other options include disabling the account with a delay or sending notifications to users and/or your administrator contacts. Credentials monitoring refers to checking the user's exact email and password as a specific pair. When enabled, Enzoic checks full credentials from Active Directory at password reset and continuously after that. The remediation options are the same, but since exact credentials being compromised is a more significant vulnerability than a password only, you might want to choose a more stringent remediation plan. In the password policy section, you can tailor your password policy with the following options. Common passwords goes beyond passwords from data breaches to reject the passwords found in cracking dictionaries that are shared by hackers. Fuzzy matching undoes the typical character substitutions called leet speak, such as replacing an E with a 3. These are patterns people commonly use and hackers know all too well. Screening root passwords will also undo any leading or trailing numbers or symbols. If your users add an exclamation mark or 123 at the end of a weak password, they actually aren't making it more secure. Enzoic also considers the specific user. locking passwords based on their username, email address, first name, and last name. And if fuzzy password matching is enabled above, leet speak substitutions will be checked here too. The repeating character option allows you to detect and prevent this common behavior that is typically used to get around your password length requirements without making the password more secure. Password similarity makes sure the user's new password isn't too much like their previous password. You can use the distance option to determine how many differences are required. On the network settings page, you can add a password timeout. Enzoic typically takes just a couple hundred milliseconds for a round trip check. If it takes longer than the timeout period to connect for any reason, the password change will be allowed to go through. If the password is compromised, it will still be caught during continuous monitoring process. And if you would like, you can route Enzoic internet traffic through a proxy in your environment. You can create your own banned list with a custom dictionary. For example, add your company's brand names or product names. Cyber criminals know that users often use passwords related to their environment. This dictionary uses contains type matching, so you don't need to enter every variation. And when fuzzy matching is enabled, it also protects against leet speak substitutions. For admin notifications, alerts are sent when a new compromise is detected and when they are resolved. If there are system errors that need attention, and to receive summary reports. These include the number of password checks and details about which users had compromised passwords and their current remediation status. This is helpful as documentation for any compliance audit. Client settings. In this area, Enzoic offers an optional Windows client that can be installed on each end user machines to show your organization's password policy on the password change screen. When an end user's password is rejected, they are told why. This includes both the policies that are set in Enzoic and natively in Windows. Reporting in the console shows a count of password change checks and continuous monitoring checks. A hover over shows more information. For example, if a match occurred based on a password from a data breach or from your custom dictionary. The third report shows all your monitored users and their current status. This can be easily exported to CSV. Enzoic's log files are also in a JSON format designed for importing into other tools. For example, a SIM to enable other alert-driven cases. With Enzoic for Active Directory, you get a fully automated approach to eliminating compromised passwords within your Active Directory environment. This provides your organization with improved security for the authentication layer you've already invested in, compliance with current industry standards, a better user experience with passwords, and a lower cost of keeping passwords safe. You can learn more at enzoic.com and register there for a free license for up to 20 users.
Alrighty.
We'll just conclude with that. The other thing that I would just say is there's a free audit tool on the site on enzoic.com that allows you to see how many compromised passwords are in your organization. And there's also that free license, so you can try it out for up to 20 users. Pricing's on the site. It's all very easy to work with, easy to make happen.
This is fantastic. And again, take a look at the white paper because we do walk through some use cases for this. I think it's fairly straightforward. We did a review of I say fairly straightforward. I mean, credentials are fairly straightforward, defending them not so much, right? You know, this is a fantastic tool to do that with. I'd endorse it 100%. Seriously, like again, you know, versus thinking about like dark web scans and whatnot. This is really at the heart of what you care about. Yeah. At the end of the day, I heavily encourage folks to go take a look at it. Josh, I thank you so much for joining me today. And I thank Enzoic, of course, for sponsoring this and bringing this to the SANS community. Go out, check out the free audit tool, certainly register for the trial. It's like getting up and running. It's like that. It's not like an extended POV process or anything. With that, I'm going to hand the webcast back over to Carol. Carol.
Thank you.
All right. Thank you so much, Jake and Josh, for your great presentation, and to Enzoic for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.